Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we are going to be in part 4 of a series that we're doing on exponents. So if you haven't watched the first 3 videos, I would recommend watching those. I'll link them below. And as always, if you want to follow along with this worksheet, you can find it at the first link in the description below. So hopping right in, like I said, I hope you have seen those first 3 videos because we're going to assume that you kind of already know how to do the previous rules of exponents. Just as a super fast refresher, from the first set of from the first video, we learned that if you have a situation like x squared times x to the 5th, you are going to keep your base and add your exponents. So 2 plus 5 is 7. So that would simplify to x to the 7th power. The second rule that we came across in the second video was when you have a power to a power, and in that case, you keep the base and multiply your exponents. So that would become x to the 10th power. And then in the last video, in the third video in this series, we learned that it's not the distributive property, but it kind of looks like it a little bit. If you have a situation where you have multiple terms in the base and it goes to an exponent, then you keep the individual bases and each base gets the exponent. So you would call that x to the 5th times y to the 5th. So what we're going to do today, hopefully will kind of almost seem a little bit instinctive, but I just wanted to slow down and run through this rule all by itself just to make sure you know how to do it. So if we have something like x to the 3rd power over x, or x to the 3rd power divided by x, it's helpful to remember that technically there is a 1 on that x down there in the denominator. So if we wanted to write this kind of expanding out those terms, I could write that as x times x times x. And then on bottom, there would just be 1x. Okay. Now, if you remember your rules from fractions, if you have the same thing, if there's multiplication going on, if you have the same thing in the numerator and denominator, you can cancel them out. So for example, I could cancel out that x and that x. Well, what would that leave me with? How many x's are left? There's just 2 in the denominator. So it would really simplify to x squared. Okay. We're going to run through a few more examples and then hopefully you'll start to recognize a pattern. What would happen if I had x to the 5th divided by x to the 3rd? Well, up top, I would have 5 x's. Go ahead and fill this out with me. And then 3 x's on the bottom. Okay. Now, using that same rule, I could cross out any sort of pairs that I can find. So, for example, that first x on top and the first x in the bottom. The second x in the numerator and the second x in the denominator, they would cancel out. And then the same thing, the third x in the numerator and the third x in the denominator. What does that leave us with? Well, just 2 x's in the numerator. X times x is once again x squared. Okay, so we're going to try to find a pattern from how do we go from that first column of those separate terms. What would be a rule that we could use to get to one term? Because it'd really be nice to skip this step in the middle. We've only got a couple more. How about one like x to the 7th over x squared? So that would be 7 x's up top. 1, 2, 3, 4, 5, 6, 7. And then 2 in the denominator on the bottom. Okay, so let's cross out any pairs that we can make. So there's 1 in the numerator with 1 in the denominator, another 1 in the numerator and another 1 in the denominator. And then how many do we have left over? Well, there are 5 x's left in the numerator. So I would call that x to the 5th power. Okay, we've got one more here. Let's just kind of skim through this kind of quickly. I'm going to have 9 x's up top. So go ahead and write those in. And on bottom, I'll have 4 x's. So perfect. Okay, let's cross out any pairs. And as you can imagine, you're going to have 4 pairs. So there's a pair. Here's another one. 3 and 4. How many would that leave over? Well, again, it would leave us with 5 x's left over, or x to the 5th power. Okay, so hopefully if you've been paying attention, you're starting to notice a pattern of how you could go from that first column all the way to the last column just by kind of memorizing a rule. And the rule here says that, like the other ones from the previous videos, we're going to keep the base. But what are we doing with those exponents to get them to turn out like the final term? Well, you're going to keep the base and then subtract the exponent. Okay, So keep the base and subtract the exponents. Take a look at that last one that we did, x to the 9th over x to the 4th. You just keep the base, which is x, and then subtract. 9 subtract 4 is 5. Okay, so that rule isn't super complicated in and of itself. The part that gets a little bit complex is when you have to add this rule with some of the other rules that we've been talking about in a single problem. Let's take it one step at a time. Look at number 1. 2 to the 7th divided by 2 to the 2nd. So what's the base there? Well, the base is a 2. So we'll keep that. And then we're going to subtract the exponents. 7 minus 2 is 5. So we've got 2 to the 5th power. Now, I always tell my students that technically that's correct. You're just not done yet. It's not simplified as far as it can go because you have a number to a number. So anytime you have that, you can either grab a calculator or however you want to find it, but you want to evaluate that. And 2 to the 5th power is 32. Don't say 10. That's 2 times 5. This is talking about 2 times itself 5 times. So 2 times 2 times 2 5 times gives me 32. Okay, let's see if we could do number 2. X to the 4th over x to the 3rd. Rule says keep the base, subtract the exponents. 4 subtract 3 is 1. Now, as a mathematician, I'm going to leave it like that. But if it makes you feel better, you can put a little 1 here. If you don't see an exponent, you assume that there's a 1. So I'm going to erase that just because that's how I always write it. But if it makes you feel better, you can put that little 1 in there. Okay, now let's use that to kind of evaluate this one, even though there's 2 different variables, a D and an E. Okay, so the rule says keep the base. So there's a D and an E. Subtract your exponents. So what exponent belongs on the D? Well, 4 subtract 2 is 2. So that'll be D to the 2nd power. And technically, if it makes you feel better, you can fill in that little 1 on the E. So technically that would be 9 minus 1, which is 8. So E to the 8th power. Okay, so that rule that we learned today in this video is not super complicated. Let's start applying it with some other rules kind of baked in. Okay, so let's look at number 4. We've got a to the 6th power, b to the 4th squared over a to the 3rd, b to the 3rd. So first thing I want to do here is take this 2 and apply it to both of the terms on the inside. Now, if this kind of seems like I'm blowing your mind, it might be because you didn't watch the previous videos. From the previous videos, we've seen that if we have that situation, we can it's not the distributive property, but it kind of looks like it. I'm going to call that a to the 12th, b to the 8th. Hopefully that didn't blow your mind. Where did that come from? I did 6 times 2 to get 12. 4 times 2 to get b to the 8th power. Now that stuff on the bottom doesn't actually change. We're going to just leave him as is. So a to the 3rd, b to the 3rd. So that's correct. It's just not finished yet. So what would we do to further simplify this? Well, let's use the rule that we found today. How would I simplify the a's? Well, it says keep the base, subtract your exponents. So I'll call that a to the 9th. I got that from 12 minus 3. And then what would be the exponent on the b's? Well, you just have to subtract those exponents. 8 minus 3 is 5. So a good final answer there is going to be a to the 9th power, b to the 5th power. Okay, moving right along. We've only got 2 more that we're going to do together here, and they're not nearly as bad as they look. So number 5, I have 3 different variables there. So I think of that as having like x, y, and z. You could go ahead and jot those down if you wanted to, and then just start looking at what exponent is going to go with each of them. What would go with the x? Well, I've got 7 and 2. 7 subtract 2, so that would be a 5. Now, again, that bottom, so there's y squared, and on the bottom, it's just y. There's only one y there. So 2 subtract 1 is 1. As a mathematician, I'm just going to leave it as y. If it makes you feel better, though, you can put in a 1 there. Typically, you won't see that like in a textbook or a standardized test or whatever. They'll just leave it blank. It's assumed that there's a 1. And then z to the 5th power, because 8 minus 3 gives me 5. Okay, I went ahead and threw one that's a little bit nasty in there, but I'll help you with it. We'll do it together. Okay, as I'm looking at this thing, my brain goes off and sees that 3rd power, like on the very outside of everything. And I know that everything on the inside of that parentheses is gonna get an exponent of 3. So like this 4 does, the m to the fourth does, the m to the third does, the n to the third does, the 2 does, and the n does. Holy cow, we've got a lot of stuff going on here. Let's take it one step at a time. Starting at the top in the numerator, what is 4 to the third power? Remember, that's 4 times itself 3 times, okay? So that would be 64. 4 to the third power is 64. How about m to the fourth to the third? I'll call that m to the 12th. If you're confused about where I got that 12, I just did 4 times 3. What about that next term with an m, that m to the third to the third? Well, now that's m to the 9th, because 3 times 3 is 9. And then last in the numerator, it's going to be n to the 9th. And again, because that was n to the third power. Okay, what about in the denominator? Well, I've got 2 to the third power, which is going to be 8. And then n to the third power, which is just n to the third power. Okay, that's correct. It's just not finished yet. So if I were to take a look at this, here's what we've got. So I'm going to do a few things all at once here. I'm going to simplify the 64 divided by 8 part. That's just 8. So my coefficients divide out to 8. Okay, if I look in the numerator here, I've got m to the 12th and m to the 9th. I'm just going to add those together. These guys are just going to get added together. So that would make m to the 21st power. Then finally, I have to apply that rule that says that we subtract when we have fractions. So n to the 9th over n to the 3rd becomes n to the 6th power. So again, none of that was overly complicated by itself. It just gets a little bit foggy when you're trying to do all of them all at once. And sometimes there's more than one way to get to the final answer. In other words, you could have simplified some of that in the numerator before you did what I did, but you would still end up at the same final answer. So this is just like anything else, practice makes perfect. But hopefully this video was helpful. And if it was, go ahead and consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.